multiplied by x to the power 4.
Okay, so x can knock off x power 4, x power 5. Can x knock off x power 4?
Yeah.
Yeah.
I mean,
Can x
yeah.
knock off x cube?
Yes.
Can x knock off x square?
Yeah.
Yes.
How does it knock off x square?
Because they're just, it's just more x's. You
Okay.
just keep putting more x's in.
Can x knock off x?
Yeah.
Yeah.
Can x knock off, say, 3?
Wait.
Yeah, you can pretend that x is 3.
With
It's
what to multiply x to get 3?
3.
You multiply it by y.
So xy is equal to 3.
Yeah, you need to make up a new variable because.
No, but you're only supposed to multiply with constants and variables like x, right? So can you knock off 3?
Okay, x times 1 equals 3.
This is an under. Yeah.
So look, do you guys want to memorize stuff or you guys want to really have a conceptual understanding?
I definitely don't
Conceptual.
understand.
Then you have to pay more attention here. See here. Because you're telling me plus c plus c plus c, but it's not plus c everywhere. Cy. Okay, x cube power 4 plus x square plus x plus 1, right? Can you knock off x power 4?
Yeah.
Yeah.
Wait.
So what do you get here?
Wait. Can I move it?
Can you knock off x cube here?
Yeah, you can knock off x cubed.
What do you take here?
In order to knock off x cubed, you would multiply it by x squared.
You want to knock off x cube or minus 4x cube?
You want to knock off minus 4x cubed, right? So
What
you have to multiply by minus 4
Wait, hold up.
x squared.
21 x. Wait. Yeah, 21.
Would it be minus 19x squared? Just a question.
That minus of minus, no? Yes,
Oh
sir.
yeah, minus.
Wait, 21 x. Oh yeah. Wait. I don't. Oh yeah.
Hold up.
Yeah, you would have to do it times 21x and then.
Negative 104x.
Right?
That's not going. If you multiply them by 104, you're going to get negative.
Right? Were you able to knock off the 4th power of x?
Yeah.
In your remainder, do you have x power 4?
In your reminder, have x power.
No.
Why will your remainder have x square?
No.
Why won't your remainder have x square?
Because you can knock it off.
Will your remainder have x? Yeah, with it.
No.
I don't get it.
No. Why is it that your remainder cannot have x square? If they were an x square, what will you do?
Wait. The reminder can't have x squared because the x got knocked off.
Yeah, but if you get an x square now, let's say I got an x square here, what will you do? Let's say I got an x square there, somehow it just showed up. What do I do in the next step?
You would multiply by x.
And then knock it off.
Yeah.
So can my remainder have x square?
No.
So my remainder cannot have x square, right?
Yeah, the x will just keep knocking
With
it out.
it, let me tell you this. Let us say you're doing 12 divided by 3. Can your remainder be 3?
Wait, no, it's 4. There's no reminder. 12 over 3 is 4.
Wait,
No,
reminder or remainder? I'm so confused.
I'm talking about remainder. Let's say
Like reminder as in I'll remind you it's tomorrow.
No.
Remainder.
Yeah, remainder. Yeah.
I don't know. I heard it being like, remainder, but I'm just.
So 12 divided by 3, is it possible? So 12 divided by 3, is it possible that you're left with 3?
No.
I have 12 apples. I need to give it to 3 of you. I give 3 first. I give another 3 first. I give another 3 first. So each of you got 3 each, correct?
Yeah. Wait.
I'm left with 3 apples. I'm left with
Wait.
3 apples.
Wait, hold on. You said you're giving it off to 3 friends.
Yeah, to 3 of you I'm giving 3 times.
Wait, wait. Oh, wait, I kind of see
Wait. I was just doing it myself this entire time, but
subtraction.
I finally. Hold up.
Subtracting
How did you put an x squared there again?
Can we please concentrate and get this concept first? If we jump the gun, we'll miss the concept. See, look. Okay. Let's say I've got 18 apples with me, right? How many apples do I have?
18.
And I give 1 each to 3 of you, right? So how many apples am I left with?
15.
15. So 18 apples, I give 1 each, I'm left with 15. Then what do? I give again 1 each. How many will I be left with?
12.
And how many
Well,
apples does each one of you have? How many apples does each one of you have now?
2.
Yeah. Then I give it again. How many apples does each one of you have?
9.
Each one of you.
No. 3.
Now how many apples does each one of you have?
Wait.
12.
Wait.
Each one of you has 4, no?
Yeah.
Wait, you said, I feel confused. It's put 12 minus 3 is 6.
Oh, sorry, yeah. Yeah. Each one of you now has 4 and you're left with 6, right? Now each one of you has how many?
3 minus 3 is 0. 1, 2, 3.
5, right? Can I say the remainder is 3?
No, because 3
You
goes
forgot to
in.
give out the other 3.
Yeah.
Why can't I say the remainder is 3?
Because you can subtract one more time. 3 minus 3 equals 0.
Subtraction until you can reach 0 or unless you can. You're not doing that. You're just taking away until you get 3.
Yeah, but how does this have to do with the x squared?
It does. Let me show you how. It
It's
does.
showing us the roots.
What do you mean by roots, Abhi?
I don't know, like where it comes from. Like
Correct.
you're not. It's like you need to know how to do the first step in order to do the second step. Right?
You can't jump 2 flights of stairs without
Okay.
learning.
Now see this. 17 minus 3 is 14.
17 minus 3 is 14. 14 minus 3 is 11.
Can I say the remainder is 5?
No, you can still take away 3.
Correct. So likewise, if you're left with x square, can I be left with x square?
No,
No,
you can
because
take
you can still
away x squared.
You get the analogy here?
Yeah, it's like you're trying to grab out as much as possible and you can't leave like as just like a visible amount right there.
Exactly. You can't do incomplete subtraction, right?
Yeah, it's wait, so would that be the difference between division and subtraction? Subtraction would be incomplete.
No, subtraction is complete, but it's just supposed to be one step.
Division, you're repeating. Divisions, repeated subtractions, multiplications, repeated addition.
Yeah, but it is repeated subtraction until the remainder is less than or equal to divisor, right?
Yeah.
Because the remainder is equal to divisor, then it means it is.
It's not really. You can do another time.
Exactly. Yeah. So likewise, your degree of the remainder should be?
The degree of the remainder should be to the degree 1 less degree than your number.
Divisor.
Wait, I don't get what he means by 1 less degree.
Wait, what?
I guess
So
that
like, see here. With it, that's what Abhi is saying. This is the divisor, right?
Yeah.
So here your degree is 1, right? He's saying the remainder should be 1 less than this power. It should be x power 0. It can't be x power 1, right? If it is x power 1, what does it mean?
It's x. You can still do something.
Correct. Now, if I have x cubed plus 1, what can be the degree of the remainder?
Wait, x cubed plus 1. You multiply by x squared. Wait, this is the divisor or the I'm confused.
Divisor.
Then anything less than x squared or anything x squared or less, it can't be. Yeah.
So x square or x or 1, right?
Yeah.
So the remainder looks like ax square plus bx plus c. ABC you have to find. Right? It'll have some x square, some x and some constant. How many x squares you should find?
I don't get the ABC part.
Because will you get exactly x square, or can it be something like 5x square or 9x square or 100x square and so on?
There's infinite possible. Not like there's every possibility can be 5x squared, 7x to the power
Exactly.
of.
So I'll call it some ax square. I need to solve for the a.
Wait, x squared? Wouldn't it be a to the power of x because or a to the power of some variable because you don't know?
No, but see, look, see here. Let's say I divide x cube plus 1.
X4.
Okay. X power 4 plus x cube I divide by x. Okay, let me take this. You're getting an x square term, right?
What?
Can you help it?
Where did the 5x squared
I
come
just
from?
added, I mean, the divide.
You can't fit that giant x cubed into a tinier x squared or x.
Exactly.
Oh yeah, yeah.
So in your remainder, you expect to see an x square. In your remainder.
Can't you just do like 1 over
Wait, let me
x?
show you again. See here.
Wait, yeah, can't you just do 1 over x?
You can't, because 1 over x is not a polynomial. No, we are only considering polynomials.
Oh, right.
This is the new problem.
Same problem. I'm just doing it again, so it's less confusing.
Couldn't you technically kill the Look, this is just a crazy random idea, but couldn't you technically kill the 5x squared by doing 1 times 5x squared?
1 times
No,
5x
but
square.
like there's the first term is x cubed. You're supposed to have that match first.
Yeah, but like I'm saying, after you do that, couldn't you technically kill the 5x squared by
You'll
doing?
get a 5x power 5, no? You'll end up creating an x power 5.
Wait. Actually, what if you just switched it around? 1 plus x cubed, then the first term would be 1 there. But then again, it's.
But wouldn't you end up with x power 5?
What if you do 5x squared?
Oh.
Couldn't you multiply that by 5x squared? 1 would become 5x squared.
Correct.
Yes, that's what I'm saying. Well,
Wait,
minus
what?
5x squared in this situation.
Wait. What did you say? What happened?
Minus 5x squared. That's going to end dirty.
Okay. So that's a very good question which you guys are asking. Beautiful question. Let us do that.
Wait, is there?
Okay, let's do that. Let's do that. See here.
We're learning.
Where?
This is learning.
Why do you say this is learning?
I don't know, because we're learning something.
They're learning.
Yeah. See, in school, all they do. I mean, it's not like I'm complaining because it's like free time, but right? They just. I don't pay. I'll be frank here.
In school, they just.
Here,
The only problem with school is here's the formula.
No, in school. No, in school, they don't teach you anything. They'll like during math class, like all the kids who just, I don't know. I'm not going to generalize anything, but there's just a bunch of kids who are trying to learn, right?
Like
And then he literally just goes, puts a problem on the thing, and then expects everyone to do it. And then it's just like, it's not even a math class because he isn't really assigning us with anything. I'm not complaining about that because I'd rather have it like that. He just gives us homework every day, and it's just, I'm not complaining because it's not hard or anything. It's just right now I think right now we actually covered systems of equations, which we already did in this math class. So I actually have to
not explaining them in like that, this kind of detail.
Okay, so now I'm showing you this kind of detail. No, will you pay attention? Okay, great. So now see, you all came up with an idea. Why don't I multiply with 5x square? So we have an idea. So what do we do? Try it out, right? Let's try it out. So when you multiply with 5x square, what will you get?
Well, if you multiply.
Okay, as Chinmay suggested, we'll just flip it around and make it 1 plus x square. X cube. Okay, what will you get? Minus 5x square.
And then minus 5x cubed. I mean fifth, yeah.
So you
So
killed
plus-
this
Oh,
guy.
then you can flip it around again.
Wait,
If you really wanted to do, wait.
So now you're supposed to kill 5x power 5, right?
Which then requires you to use 5x squared again.
5x squared.
It's the loop. It's like those repeating
Wait,
decimals.
but that's minus 10x.
The repeating
squared.
decimals are proud of us.
Wait, no. That's minus 10x squared, right? So
It's
Wait, what do you
literally-
mean minus 10x?
yeah, that's minus 10x squared then.
Chinmay is either using his full brain power and going beyond the limit of human beings, or
So
he's
see here what's happening. Again, you're getting a 5x square.
And then you'd have to do the same thing again. It's a loop.
No, you can't.
Wait,
Oh wait, no, never mind. The one I just forgot.
wait,
Keep
what?
going on
I'm
forever,
kind of
right?
confused now.
Okay,
Hold
so
up.
it's an
Wait.
endless loop that never ends.
Minus 5x to the fifth, right? You got
Dude,
that.
it's like your dividend is 1 and
And then
your
you get
dividend is 1. Divided by 1.
Wait. 1 multiplied minus 5x fifth minus 5x to the... Wait, how did you get minus 5x squared?
Dude, it's 5x. It's 0 minus 5x squared. It's minus 5x squared. That's all it's left.
No, like...
Wait. Are we
No.
literally?
Once he got... Look. I'm going to annotate for 1 second. Well, just a little
It's
bit.
just like doing 1 divided by 1, which you
Here.
just keep
Look at this. Look at this, right?
multiplying by 1 to
Wait,
get 1.
You see that?
Let's go one at a time. Let's listen to Chinmay's question. Chinmay, it's a
Okay,
little
look,
confusing when you name yourself Abhi. Yeah, go ahead.
Oh, yeah, my bad.
Yeah.
Yeah, just look at this,
Huh.
right? The minus 5x... Wait, where did it go?
That got cancelled.
Okay, but yeah, it's fine. You guys saw it. So the minus
So this
5x
had to be
fifth,
plus.
right?
Sorry, my bad. This had to be a plus. Okay. So Chinmay, is this okay now?
No, like not that, because you got the 5x to the fifth, right? And then if you're still multiplying, I mean dividing by the same way, like in the order of 1 plus x cubed, then you would get 5x to the fifth, right? So then you would subtract that, and then x cubed multiplied by 5x to the fifth. 5x to the fifth would be 5x to the eighth.
Yeah, but you...
It's a cycle.
No, wait. You didn't multiply by x power 5. No, we multiplied by x square to knock off this guy. We switched the terms. Yeah, what you're saying is right. I should have ideally got... It's a good question again, which he's asking. I should have ideally got 5x square plus 5x power 5, no? I'm flipping the order and writing. So that I can knock off 5x power 5.
But you need negative 5x if you really want to cancel it. You're just gonna end up.
No, but I'm subtracting, no? I'm subtracting 5x power 5 from 5x power 5.
Wait, I'm so confused. Wait, can you like walk through the entire thing of what you just did and how it even
Let's do
is
it again. Wait, relax. Let's do it again. Okay, let's keep things simple.
We're learning. We're not here to just get the formula. We need to learn why this formula works.
We're trying to do that.
Okay. So, oh, sorry, it was +1. No? Now, as Chinmay suggested, we'll change it to correct.
Yeah.
Is this okay?
Yeah.
Yeah.
Is this okay? Now, what I'll do is I'll rewrite this again as x cube plus 1. So that this x cube can knock off that x power 5. Would that make sense?
Yeah. Wait, yeah. Why are you rewriting plus 5x squared?
So that I can knock off this guy.
What do you mean? What do you mean?
See here, like this way.
I'm getting confused.
Yeah, but like, just because you change the order doesn't mean you have to put anything else. Like, what happened there?
Wait, I still feel confused.
I multiplied
Yeah,
x cube I multiplied x cube plus 1 with 5x squared.
I'm still a little confused about my question. Was he asking? Was he
No,
saying?
I'm saying like, how do you even end up with the 5x squared over there? And
Because it is
wait,
x cube plus 1 into
Vidit, wait. X cubed plus 1. Right. Wait, so yeah, but like the question is like it says 5x to the 5th, right? And if you're going with procedure, like with the procedure, right, then you would be doing 1 multiplied by 5x to the 5th, subtract x cubed multiplied by 5x to the 5th, so you would get 5x to the 8th. So how are you ending up with another 5x squared over there?
Exactly. So
and the 5x squared on the bottom.
That's a good question you've asked. So there are two options I have here. Okay, there are two options I have here, Chinmay. One option is that let me put one option in green and one option in some other color. Okay, so one option is that I multiplied with 5x square like this. I multiply with 5x square, so I'll get 5x power 5. Okay, let me not flip the order also.
Yeah, again, my question is, how do you get that 5x squared?
Just give me 1 minute, your answer will be clear. Okay, just 1 minute, your doubt will be clear. Just 1 minute. So let me go with the same 1 plus x cube. Okay, to make life simple, let's go with 1 plus x cube only. Now I've got two options. One option is I multiplied with 5x square. So I get 5x square plus 5x power 5. This is one option, right? Now the other option which you said is I have 5x power 5 here, okay, and I multiply it with 5x power 5. So I get plus 5x power 5 plus 5x power 8, right? And I subtract. So I get minus 5x power 8, right? In option 2, I get 5x power 8. In option 1, I get minus 5x power 5. Which option is less messier?
The green one.
Why? Just 1 minute. Let's clarify his doubt and then I'll come. Yeah.
Exponent is smaller.
So do you see why I wanted to go with first option and not the second option?
Yeah, I know, but like that's not my question. I'm asking like the top of the line, right?
Yeah. Yeah, because I subtracted by multiple of 5x square, no?
Subtracted by a multiple. Wait.
So what are you writing on top? You're writing how much you removed. See, let me give you an example.
Let me think.
Okay, see. Chinmay, let me give you an example. Let's say I'm dividing 109 by 8. Why do you write this 1? You subtracted by 10, right?
Oh, wait. I think I get it. What you're doing is, so technically like you have x cubed plus 1, right? So one option is you could do x cubed multiplied by 5x to the 5th, right? Like into 5x to the 5th, whatever you want to say, right? That would get you 5x to 5x squared, right? But then if you flip the order to 1 plus x cubed, you'd get 5x to the 5th. causing you to have to multiply the x cubed 2 by 5x to the 5th. Yeah, okay, I get it.
So I'm trying to make my life simple at each step. So, right? So why am I, so in the first place itself, why am I not multiplying with 5x square? Because if I multiply with 5x square, while I may knock off 5x square, I end up creating a bigger monster 5x power 5.
Yeah, right? I'm gonna be honest. You know how you wrote 5x squared in Brown? I thought you put that in the lane where negative, like where the dividend is supposed to be.
Okay.
I don't know, like the dividend was right under it, but like I don't know why I didn't. Yeah, it's I got it, but like but it was still clarification for a potential doubt that could come in the future. So
yeah, great.
Yeah.
So with it, go ahead. A lot of questions. Yeah.
I have a doubt about you. My doubt. I don't get what you were saying.
No, yeah, yeah.
You said it way too fast.
No, because you know how he wrote 5x squared, right? So both numbers that he
wrote 5x squared like
here. I'm gonna have to annotate to explain why I thought this, right? Like I'll erase it after.
Pointy arrows and fun colors.
This and that, right? So they're the same number, right? So yeah. I got confused with like what the dividend was and what the answer actually was. So I thought he was placing 5x squared over here into the dividend lane. Like I thought he was adding a number to the dividend, but because like both numbers were the same, so I kind of got confused. But either way, it was still like clarification.
What was this?
For a doubt that might come in the future.
I still don't get what you're saying.
You know how there's a dividend and a divisor. The dividend here.
With it, just listen to him carefully. No, I'll explain. With it, listen to him.
The dividend here is negative 5x squared, right? I thought he added 5x squared to that dividend. Because, like, wherever you put the answer where it says negative 5x squared plus 5x squared, that's where you put it. Like, the numbers were the same. I thought that's what that he was putting in the dividend. But then again, that would have meant you would be dividing by 0, which I should have expected.
I think it was a little confusing because the quotient was bigger than the dividend.
Yeah. And like the numbers in the dividend and the answer lane were the same, so I kind of got
Yeah.
How's a quotient bigger than the dividend? If you're pulling something out of something, how can that thing you pulled out be bigger than the original thing?
No, that's not.
It's not literally like, big, but it's bulkier, right? I mean, it has more terms. This guy has more terms, but all of them are zeros, so we didn't write them.
Oh, yeah, that makes sense.
And even then, this is an illogical step. So when it's illogical, you expect to get too many terms which are just killing themselves anyway. Minus 5x squared plus 5x squared, minus 5x squared plus 5x squared, minus 5x squared plus 5x squared. And you're still left with the remainder.
It's a complete cycle of unnecessary boredom and work.
Yeah, I think Abhi has a question. Go ahead.
I don't.
You raise your hand, no?
No.
Okay.
I think he was just like raising it.
You were stretching, huh?
I had an awkwardly placed position that looked like I was raising my hand.
Okay. And Vidit is so happy. Whenever Abhi does something awkward, Vidit gets very happy.
I don't know why. He just does. See, there are 2 reasons I came to this class. So my first and main priority is to learn math, but I have this side priority of like being funny. It's like a side priority though.
Okay.
But yeah, we need to get back to math and now.
Yeah. So does this answer your question, or why we cannot have 5x? I mean, why we cannot flip and try do that? We can do that, but we end up creating more mess. So in general, what is our discussion? If I have an x cube plus 1, I would expect to see an x square. But do I know what coefficient I can get with the x square?
Wait. If you haven't, I don't get. I'm confused.
Okay, this is your divisor. Okay.
And that's the dividend. Oh no, that's the remainder.
Wait, how can you tell the remainder just from the divisor?
No, I mean, you're guessing what it might be. You expect to see, exactly. So you expect to see an x square, right? If the divisor is x cube.
Wait,
Do you expect an x cube in the remainder?
can it also be x?
Yeah, absolutely. You'll expect an x square, you'll expect an x, and you'll expect a constant, right?
Wait, but then how do you put that in mathematical terms?
Yeah, you need to find the a, b, and c. Okay, let me give you an example. Let's say I'm dividing x cube plus 1 from x power 4. What's the remainder?
There are wait.
It's minus x, no?
Yeah.
One possible remainder is minus x. Now let's say I divide x cube plus 1 with x power 4 plus 7x square. What's the remainder? I multiply with x cube with x. You get x power 4 plus x minus. So you get 7x square minus x, right? So one more possible remainder is 7x square minus x.
How does the remainder become how does the remainder not be constant?
See here.
I mean, how does the remainder like so different things?
Okay, let's see one more example. I'll answer your question. Just see one more example. I'll answer your question. What do? You multiply with x, x power 4 plus x minus, cancel minus 7x square minus x plus 5. Can you kill further?
Since x cubed can't fit into 7x, you can't kill it.
So are these three all possible reminders for x cube?
I guess.
Because did I give you 3 examples where these 3 are reminders?
Yeah, but isn't the reminder just what's left after? So technically, wouldn't it be this the dividend? So the dividend would technically be the divisor times some number plus the remainder.
Correct. That remainder here is 7x square minus x.
But then how can the remainder be 3 different numbers? It's like, isn't it just pulling out something
Yes,
that
good question. See, x power 4 plus 7x square is equal to x cube plus 1 into x plus 7x square minus x. So this is your remainder. This is your divisor. This is your quotient. Remainder is what you're left with. You're left with both x square and x.
X is just something, right? Like
Wait,
last
how
week
did
you
you
do a bunch of scribbles instead.
wait?
Yeah. So, but why
Where did you get the
both x square
remainder
and
again?
x? Sorry.
How do you get the remainder again? Like for every problem.
So the idea is that
One minute. Let me complete this. We just did division, no, Chinmay. We just did division and saw what we are left out with. I did x cube plus 1 into x. I'm left with the 7x square minus x.
Wait, yeah. So like what I meant is for every time, do you have to put it into that variable like x?
Put it into
like if you're doing like x squared plus 5 and you're trying to find the remainder, would you have to divide into x?
No, you'll take quotient to be something appropriate, right? Here I took x because I want to knock off x power 4.
Wait,
Wait, you were dividing. Wait, hold on. What was the original dividend again?
Okay.
Okay.
Okay, see here. See here. X power 4 plus x cube plus 1. How do you divide? What do you take as the quotient?
You can just write x and the remainder would be 0. Oh my god, it's the perfect problem.
Okay.
Equals perfect.
Okay. Now, Chinmay, if I take this one, what will you take as a quotient?
X.
right? If I take what will I take as quotient?
Well, first you would have to do x, get rid of the x to the fourth.
X4 goes X and then 5x, 5x,
And then
5x
you the
minus
5x.
X minus 3.
So yeah, you need to do
Wait,
2x.
wait. Isn't minus 3 just an extra unneeded complication? Why does that have to do with that minus 3? Oh,
Because in
wait.
the real world it would appear like that. I mean, for
2 minus X.
Chinmay, how do you do this? How do you do this? What do you take as a quotient?
You wait, I'm confused.
In this
What do you
case,
think?
5x.
Correct.
Oh yeah, right. 5x.
Right? Are all the 4 cases clear? Yeah, we did. Go ahead.
Wait, 5x minus 5x minus 7x squared is another piece that's still remaining when we try to take out that other piece.
Correct. And we can't help it, no?
Yeah, but then why do we have to add the 9 in? Isn't that just another
Because the 9 is left out, no? We are reporting whatever is left out.
Oh wait, so the remainder is basically
could get rid of
the
9.
first leftover terms when you multiply.
Remainder is basically whatever you're left out with.
No,
So
it's not.
Okay, guys, relax. Let's see an example. Okay, let's see an example. Let us say you've got 1093 apples. Okay, 1093 apples. And you need to distribute them among 7 friends. Would you give one apple? Would you give 7 at once?
Would you give what?
7 at once. You know, take one.
That
Take one.
so weird. 7 at once.
Maybe, but just to make sure everyone gets equal and be safe.
So would you give 1 to each in each distribution? Okay, with it, take 1. Okay, Chinmay, take 1. Okay, Abhi, take 1. What would happen if you keep giving that way?
It would take way too long.
Going on one and one and one and one and
So
taking something.
what would you do? At once you give?
Like 7 or something.
Can we give 100 at once first?
Yeah, we can get rid of that.
If I give 100 at once to each,
Oh my god.
how many did I give in all? If I give
Yeah, then
100,
700. This is like
700. So I gave away 700.
wait, this is like the mental match strat,
Exactly.
right?
Yeah, now I have 293. So how many do I give at once? How many
You can
tens?
give away, I don't know, 30.
Can you give more than
40.
30? Yeah.
Yeah, 40. 40 for the easy money, and then you just give 1 more. And then you have 6 remaining for yourself.
Yeah, you can't give away 6. So what? So what is the remainder? Whatever you're left with. And what
So
are
you
these?
go
What are these 100?
When you're just like
This 140 and 1 are whatever you're giving away. So this X is what you're giving away. X is what you're giving away.
so
Mhm.
then can you use the
Because
okay, what about x plus 5 into x to the 4th plus x cubed plus x squared plus x plus 1? Would the remainder be 521?
I'm confused.
Yeah, it would be 521. The previous question. Yeah,
Okay, okay.
I was confused by what you were saying.
No, I'm saying the number on top is what you're giving away to each person, right?
Yeah, that's the piece that's being given up.
That is a quotient. And the number at the bottom is?
What you're left with because you can't give away anymore.
Exactly. So now your question was, why do you have to report the 9? It's like asking, why do you have to write the 6?
Okay, yeah, because like
Because it
I
exists.
was asking why. Yeah, I was asking why you got like 3 remainders. So
Yeah,
technically you won't get 3 remainders all the time. You'll only get it in certain cases.
Yeah. It's not 3 reminders. It's 1 reminder, which is composed of 3 terms.
Yeah.
So
that's you can't give away from that little piece there, that 5x that I added, that you added 9 to. You can't give away anymore for that because that's like a little remainder in itself. So you're adding the 9.
Yeah.
Okay.
So now,
Yeah, and a lot.
yeah. So now, do you see that? If my divisor has a degree of 3, I expect to have a remainder with an x square coefficient, with an x square term, with an x term, and with a 1 term, right? Do I have an x square term here? I do.
Actually, no.
I do, but that has a 0 coefficient. Do I have an x square term here?
No.
Okay, so can I have a common pattern for all the 4 reminders?
It's just x. No 1. Well, there's 5, but no 1. No, there's no 1. No.
There is 1 here, right?
It's
What's the
just
common pattern for all the 4 reminders?
there's just x. There's no x squared or anything. It's just x.
There is x square, right? 0x square, 0x square, 5x square, 7x minus 7x square.
Oh, you're talking about the yeah. Wait, hold
What
on.
is the common pattern for all the reminders? All the blues.
There's something x squared plus or minus an x, and then you have some sort of number next to that.
So can I say all of them are like ax square plus bx plus c?
Oh. Even so, what you're doing is you're writing all of them like that.
That is what is called abstraction, no? I don't know what it is, I'll find it out. ABC. It's like, I don't know your name, I'll call you X. That's algebra, right?
Yeah, I just call you him because I don't know your name.
Yeah, you'll call it X, you'll give it a name and then you'll find the name later on. So you know that you're going to get an x square, but what is the coefficient of x square? You don't know. So you'll call it an a for time being.
So what you wait. Now you're going out to find out what wait, no, give me a wait.
He's probably like right next door, but because of the virtual background, we think he like disappeared into like the depths of space.
Just walking around. I can't sit all the time.
Yeah, but because you're in the virtual backgrounds, it looks like you went into like the depths of space.
Yeah, go ahead. I'm listening. Go ahead.
I can't get my question because for some reason. So wait, but now I can't really get I can't remember the point of like writing ax squared plus bx plus c. Was that like the format for like finding the that was for yeah, I feel confused again.
Yeah, so see here. Now let's find the remainder for if x square plus 1 is the divisor, what do you expect as a remainder?
X squared plus 1 was a divisor. What would you expect as a remainder?
Who are the guys who might show up?
It's probably there's probably going to be an x somewhere.
And
some number.
So can I say it is some bx plus c?
Yeah. Wait, could bx not be could be the other a plus b plus that a squared bx that thing? Could technically could it only be ax plus bx instead of x squared? Because then you could have b as 5 and x or something like that.
I didn't get your question. It's too long.
No, you know how you have ax plus bx?
Okay.
You know, regularly it's ax plus bx squared. Could it be written as ax plus bx? B being b with the other x?
But why would you want to write it as ax plus bx? It would just be a plus bx, right?
Yeah.
That's still an x. So when you say bx plus c, what are you saying? I've got some x. How much? I don't know. I'll call it a b. I've got some constant, how much I don't know, I'll call it a C. You're saying I'm getting some packets of X. If you have A packets and B packets, club them together and say A plus B packets of X. No, that's just one variable. Why would you want to take 3 variables when 2 variables can do the trick? Okay, now let me demonstrate something to you. It will be clear. Let me demonstrate something. Let's say I want to find the remainder when x power 5 plus 3 is divided by x square minus 1. Right? Chinmay, are you there?
Yeah, I'm there.
Your video went off. So, okay. So if I divide by x square minus 1, what do I expect to see in the remainder?
The guys that would show up would probably be something less than x, because you can still pull out like less than x squared, because you can still pull
Less than
out
x can also show up, right?
You know, I meant like x squared, because you can still pull out any x squared or above.
So can I say x square minus 1, which is my x power 5 plus 3, which is my dividend, is equal to this thing into some quotient plus the remainder, which is bx plus c. Can I say this?
Yes.
And this is true for any value of x?
Yeah, that should be possible.
So then I'll put x equal to 1, because at x equal to 1, this guy gets killed.
And then the other guy gets killed because that guy got killed.
So this, what is x power 5 plus 3 when x equal to 1?
Wait, I have like a really crazy idea.
Wait,
Can
I this idea, I need to write something down.
What if x equals 1s, then technically these wouldn't be part of the remainder, and you could divide further and put these into the thing.
Correct. But then we are trying to find a remainder which is general, not just for x equal to 1. Bx plus c is general. It is for any x.
Yeah, like it works for any x, but technically you could divide further if potentially x equals 1.
Yeah, if x equal to 1, you can't divide, it becomes 0.
Yeah, which means that you don't have like, you know, a remainder anymore.
Yeah.
But in general, that makes sense.
Yeah.
It's a pretty good general.
Yeah. Now, if I put x equal to minus 1, will it still kill this fellow off? X square minus 1, will it get killed when I put x equal to minus 1?
I guess.
Minus 1 square minus 1? Minus 1 square minus 1 is 0. No? So I'll put minus 1. So I'll get minus 1 plus 3 is equal to 0 plus minus b plus c. Right? So I'm getting 4 is equal to b plus c and 2 is equal to minus b plus c. So from this, can I get c is equal to 3 and b is equal to 1? 2 equations, right? 3 and 1 there. The sum is 4 and the difference is 2. So what did we do here? I don't know the b, I don't know the c. See, I know one piece of information that the remainder looks like bx plus c. Right? So I assumed it to be a bx plus c. I said, okay, let me put 1 and see what will happen. Let me put minus 1 and see what will happen. I got 2 equations. Bingo. I got b and c and I'm done. So from this, what are you saying? B is equal to 1 and c is equal to 3. So it is x plus 3, which is the remainder.
Wait.
That's how we did it.
Now I'm getting a little confused again. How did you get x plus 3 from there?
I got from this, you get b is equal to 1 and c is equal to 3, no? From the 2 equations.
Yeah.
What was it? X power 5 plus 3 and x square minus 1, right? What did you get? You got b plus c is equal to 4 and minus b plus c is equal to 2. You add them, what do you get? 2c is equal to 6. So c is equal to 3. If c equal to 3, how much is b?
B is 1.
And what did you say the remainder was? Bx plus
C.
c. B is equal to 1. c is equal to 3. So how much is bx plus c?
X plus 3.
So how did we hunt down the remainder? We said it is some bx plus c, and then we hunted down.
We hunted it down by trying to gather different, like, we're trying to just get rid of as much of the equation as possible.
So now see this. If I actually do it,
Wait, negative x cubed.
was it x power 5 plus 3 only?
Wait, hold on. 3 minus negative x cubed. Wouldn't that be 3 plus x cubed?
Correct, yeah. Bingo, right?
Bingo. Wait, that the one wait. Color. This thing is x, right?
Yeah, that becomes plus x because it was a minus x, no? Now, let us say I give you x power 101 plus 3 and I ask you to divide it by x square minus 1. What would happen if you kept on dividing?
It would eventually get to a boring point and you just keep
But instead, if you just write x power 101 plus 3 is equal to x square minus 1
times blah blah blah.
Plus, because this guy is x square minus 1, whom do you expect to show up in the remainder?
Plus bx plus c. Wait, the c can be a constant because b can be 0 and then you cancel out the x. And
Absolutely, it can be constant if b equal to 0. So now you can put x equal to 1 because then this guy gets knocked off. Anything which knocks off the q, because q is unknown, right?
Wouldn't the remainder be 4?
At x equal to 1.
bx plus c.
And if you put x equal to minus 1, you'll get 2 is equal to minus b plus c.
No, I mean, no matter what, could the remainder be 4? Because let's say we would do the x times x to the 99th power, cancels out the 101. The negative 1 becomes negative 1 still because of the multiplication thing. 3 plus negative 1 is going to be minus, 3 minus negative 1 is minus minus, so it's plus. So 3 plus 1 equals 4, which means you have 4 left over, right?
Wait, I'm still not getting this.
If you put x equal to 1, what is the left-hand side? If you put x equal to 1, left-hand side is 1 plus 3, right?
I'm still not getting this.
Wait. Did you get the equation dividend equal to divisor into quotient plus remainder?
Yeah, that makes sense. But it's
then I substituted x equal to 1 to see what will happen. And I also substituted x equal to minus 1 to see what will happen.
Yeah. Oh wait, you did minus 1 and 1 because that would cancel out.
Both of them kick out the q, no?
Yeah, they get rid of the 1 in the q and then they leave everything else.
So I get 4 equal to b plus c and 2 equal to minus b plus c. So I get b equal to 1 and c equal to 3, x plus 3. Is this convenient, or doing that x square minus 1 into x power 101 plus 3 is convenient?
This is definitely more convenient.
Okay. But how is this problem? See, in your school textbook, you're taught only with, x minus a or x minus b. There's no square. But here in the class, I took square, and next class, I'll take cube also. Why am I giving you square and cube?
Broaden our ideas so that when things get more complex.
It's more delving into logic and not just.
And also because you shouldn't be stuck that the remainder is always c. That the remainder is just one term. In algebra, the remainder can have a group of terms coming in. That when we generalize, when we see a general case, the learning is broader. And we get to exercise a brain a lot more.
Much more fun.
Yeah. Maths is fun and maths needs exploration because not everything which you need is inside the textbook. You'll have to use the raw materials of the textbook to make something of your own. Textbook just gives you raw material. Textbook is fantastic, but textbook has to open up the opportunities for more. There are people who call it bookish learning. Those are people who don't understand how to read a book. Anyone who calls something bookish, I lose my respect for them. because they don't know how to read a book. A book never asks you to confine yourself to the book. A book asks you to fly with this as the foundation.
It's like saying a nest is telling a bird to stay on the ground.
Sorry, it's like
saying a nest is trying to keep the bird on the ground.
Exactly, right? Nest is just a foundation. I mean, you can go take some rest, and when you're ready, you can just go fly, explore, and come back, right? Book is just like a safe haven where you go there, relax, nurture your ideas, and then take off.
Read the Adventures of Theodore Boone.
Sorry?
Read the Adventures of Theodore Boone.
I didn't get your question.
No, that's a novel series. I just read one book in it. I happened to read the last one.
The book gives you like the power. What you do with it is up to you.
Yeah, exactly. And the point is, you know, the most beautiful thing about books or reading is they help you meditate with the minds of others. They help you meditate with the minds of other thinkers. Isn't that fantastic that your mind can be in sync with the mind of somebody else?
Wait, how do you put in sync with the other person's mind?
Because you're both thinking about the same basis. They might go to different branches, but it's the same basis, not like different places they're coming from. So all the same.
Like that, like a different branch on, like one branch on branch 1 and branch 2 from the same tree.
Yeah.
He's saying both of you are thinking of the same core idea in the book. When you read a book, you and the author. Let's say you read Martin Luther King, right? Or let's say you read Abraham Lincoln. So you're meditating with the mind of Abraham Lincoln while reading Abraham Lincoln's book. What he's thinking, what his thoughts were, what was he going through, and so on. So books are fantastic because they help you meditate through the mind of the author. So, and with it, it's good that you're reading these books, but it's important that you start reading non-fiction as well. You start reading about leaders, you know, business leaders, technology leaders, psychology books, so various genres, right? You start reading technical and scientific books as well because they open up a lot more possibilities for you to understand the world around.
Yeah, I saw this. I read this book called The Why, which is like 1,111 answers to everything.
But you know what, with it, I would invite you to read a different genre of books which don't give you answers but which give you questions.
Wait, what are they?
A genre of books which give you questions and not answers. Normal people read books which give answers. CEOs read books which give them questions.
But then what are those? Wait, is it every book?
A lot of good books leave you with a lot of questions for answers which you think about, not answers which they give you, but answers which you think about.
And you guess what's gonna happen.
Exactly, because the world has more questions than answers. And what we've got to learn is the ability to find the answers ourselves. Because not every book or every person would have an answer to every question we have. Those are research questions. Research questions are questions which you find out yourself. Google can't answer them for you.
It's science.
I mean, it could be science, it could be literature, it could be design, it could be any field.
No, like that's science, isn't it? Like method of finding.
No, that's not only science. That's not only science. Even literature tries to find answers. Even design tries to find answers. Economics tries to find answers. Every subject tries to find answer. Every subject has researchers, right? In the university, do they do only science?
No, the Harvard does law, something.
Exactly. So every department is finding answers. No, every department is doing research.
I feel like a good example of this is like social studies is really obvious. You have to do it in every, but social studies, it's obvious. Like if you take a social studies test, you'll see the first few questions are memorizing. Those are the easy ones, but the more important ones near the end, these ones are the ones that are the most important and they care the most about because those ones near the end are usually like your thinking. You need to figure out the answer on your own with the info that you have.
That's what my reading teacher's like. She says that that reading isn't about like what isn't like a textbook's answer or what you should be interpreting from a book, but it's like what you do, what you interpret.
Yeah. So guys, I just leave you on this note. I think, see, can I tell you something which you three will not like?
What?
Wait, I need to clear up background noise. This sounds very important. My importantness is coming with me.
Chinmay, can you switch on your video, please? Yeah, your video went off.
Oh, you
In
got
my-
your
Is it on now?
Importantness and everything is coming along.
So see here, when I compare, see, if I were to compare you guys with, your counterparts in India, right? 7th graders in India. You guys are in grade 7, right?
Yeah, but in India, I guess we would be in grade 8 or something.
Actually,
Oh,
I would be in 9th grade.
Oh, is it? How old are you?
Yeah. It's weird because, well, I'm 12 right
started a
now,
year
right?
earlier in
Turn,
India.
listen,
They
listen.
started a year
So,
earlier in India.
no, because like when I came here, right? I came here in 1st grade. I lived in India for like 3 years, right? I did 1st, 2nd, so yeah, I did 1st and 2nd, and then I was about to go to 3rd, but then I came. Yeah, that was just my mom, but yeah, but I don't know. I guess it was because I was born in January.
No, see,
Yeah.
even in India, 12-year-olds are in 7th grade. You do a plus
They
5 to the grade.
Really?
Yeah, you do a plus 5 to the grade. You do a -5 to the age and you get the grade.
Wait, I thought that in India they started a year early the school.
Oh, then I
Because I thought,
In
because
India,
like
people turn 18 when they land up in college.
Oh yeah, they do the looking year, right? Because technically, while we're technically the same age, literally I've been on the earth 1 year older than a 12-year-old in India, because in India they do the year that you're getting to, while in America they do the year that you're on. That's the difference.
Yeah, see, technically age-wise and grade-wise, you guys are kind of doing okay, same. But I'll tell you something. You guys have an advantage compared to a lot of the Indian kids because your English courses are quite good. Okay. But then even in the US, your English courses probably expose you to good fiction and stories. But it's important to expose yourself beyond fiction and stories. Right? For a leadership role, exposure matters. What you read matters. Because all the leaders read a lot of books. They read a lot of books because they get to know a lot of things happening around the world. As I said, a book is an invitation to meditate with the minds of so many other people, especially people who've seen a lot of the world, who've got perspectives which matter. Not all perspectives are equal, right? Some perspectives matter, like say a Steve Jobs or a Satya Nadella or a Sundar Pichai. They've got a nice understanding of how to make the world better. So point number 1, I think you guys have an advantage in terms of your English curriculum because of the rigor and the kind of exercises. When I say rigor, I don't mean tough, but I mean which makes you acquire that skill by testing you with new conditions, doesn't leave you in a comfort zone, changes the conditions to make sure you actually learn, rigor in that sense, that you're not left in a comfort zone. You're poked in so many ways, so you eventually find out, and you're not in one comfort zone. So you have that rigor in your language curriculum. That's fantastic. But where I think Indians do really well, is in India, there's a lot of hunger, right? So in 1947, when India got independence, only around 25% of India could read and write in one language, even mother tongue. People couldn't even read and write in Telugu, let alone English. Telugu or Hindi or whatever their mother tongue is here. I mean, there's so many mother tongues here in India, diverse country, right? So just like US. So India was a very poor country. I mean, even now India is a poor country, but yeah, there are a lot more people who earned well now compared to 1947. Because there's a lot of hunger in India, Indians have always been very ambitious. That I want to study well. I want to go to a good college. Those are the Indian roots, right? So that's why Indians go to US and they work very hard, and employers like Indians, right? They work harder because they've come all the way from India to US just to work. So they want to work hard so that they have a better life than what they had in India. So Indians are very competitive. And when you talk of this exam called IIT JEE, I have students who prepare for IIT JEE. IIT JEE is the toughest exam in the world. The IITs.
Wait, is it like
sorry?
the ACT? Wait, is it kind of like the ACT here or something like that?
Yeah, but it's 100 times tougher than ACT.
Mm-hmm.
And the IIT JEE, the IITs have an acceptance rate which is worse than Harvard.
What?
Yeah.
IIT or wait, is it like IIT?
Yeah, IIT. Yeah, their acceptance rate is worse than Harvard. I mean, in Harvard, maybe it's around 4% or 3% or something, which means out of every 100 people who apply, 3 or 4 get in. In IITs, around 16 lakh write the exam. That's like 160,000 people write the exam. Right? Sorry, not 160,000. What? 1600,000 write the exam.
Wait,
and out of
what
1600,000,
is it a college?
the number.
Wait, I just
1.6.
16 lakhs is like 16 times 1500.
Oh, 16. Right? Oh.
These many people write the exam every year for roughly around 10,000 to 20,000 seats. You get it?
It's like 1 in 80.
Yeah, 1 in 80. Harvard is like 1 in 20 or 1 in 15 or something like that.
It's like 5%, I think.
Wait.
So yeah, 1 out of 20.
I remember, oh yeah, now I remember. Long ago I remember seeing you in the TEDx talk.
Yeah.
Yeah, my dream college is probably it was MIT, but then after thinking about it, like I realized the only job that does something is probably a surgeon, because
MIT is fantastic. MIT does great research. IITs do not do that good research. IITs do not do that good research. I'm not talking about the college. I'm talking about the exam. IIT JEE, the acceptance rate is what? If you look at it this way, it's 1.6, 1 by 80, right? 1.25%. Out of 100, only 1.25 people get in. So, which is why even in US, there are a lot of IITians who come and work there. Companies love IITians because these are people who study really well, who have great logical thinking. See, ACT or SAT ask you questions, but IIT JEE asks you some of the toughest questions on the planet, which test your logical thinking. So now it's not about what exam you write, but it's like, would you want to challenge yourself constantly to do tough problems and to keep getting better?
Definitely.
That's the point I want to say. So don't be happy just because you're getting 100 at school. When I was in my 8th class, I finished my 9th class maths textbook. When I was in 10th, I finished my 11th. When I was in 11th and 12th, I was doing a little bit of college textbooks. So I have 2 Olympiad medals in mathematics. When I was a first year college student, I defeated 2nd year and 3rd year college students, and in entire Maharashtra state, my position was 2nd position. Entire state in India, Maharashtra.
Wait, you defeated the entire state?
I don't know much about the Indian geography, but a state is a state either way.
Yeah, we've got around 29 states here. Yeah. And bigger population than US.
Well, yeah, population is way bigger in India.
Yeah. So the point is, when you compete with yourself, right? When you're constantly figuring out, you can go take on Olympiads. The problem which I gave you, ax square plus bx plus c, is an Olympiad problem. It's not a normal textbook problem. Because the learning value of Olympiad problems is a lot higher than the learning value of normal textbook problems. Because they make you look at new approaches. Your existing approaches will not work. You have to modify your existing approach. You have to be creative in how you modify your approach.
Yeah.
It's like the movie It's like the movie I saw. It's called 3 Idiots.
Yeah.
There's like this one guy who just kept looking at the textbook all day.
I remember when we were little and not as competitive. We went to this one. They do a school math Olympiad that's a little easier, so everyone does a little okay with 4 out of 5. But all the problems, none of the memorized methods we had, we could never use. I mean, no one did that because
there's a thing on my iPad where it shuts down. It won't let me use it at 10 o'clock. So when does the class end? Because I
Yeah,
might
it's
have
done
to
now.
ask
It's
my
done now.
mom
You
to
guys can.
extend it.
So I'll see
Huh?
you guys. Yeah, it's done. I'll see you guys on when Saturday, right? No, Sunday.
Sunday.
Sunday morning. Yeah.
But
Wait,
Saturday.
my dad
Saturday,
said there's
Sunday. Yeah.
class tomorrow.
Sorry.
My dad said there's a physics class tomorrow.
Yeah, I'll tell you. That's for Vidit, no?
Wait, wasn't
Yeah.
it?
If you guys want to come, you can come too. I'll schedule and tell you guys. Physics
Yeah,
class.
I might be. I don't know for sure. It depends on how things work out with everything.
I thought it was 10, all three of us at 10:30. You just said
Yeah, but your dad said he'll talk to both of them and then check if they're interested. So because I didn't yet tell him the timings, I'll have to work out the timings and tell him today.
Oh, because my dad told me 10:30.
Okay. No, I need to work out the timings because I'm going to club you guys with some of the Indian students. So I have to work out the timings. Yeah.
Okay. Bye.
Bye. Take care.
Sidiv is going